In this video, we'll look at increasing, decreasing, and constant portions of functions, as well as maximums and minimums. So starting out, let's look at this increasing, decreasing, and constant. Now, we read a graph from left to right in college algebra. And anytime you have a graph, you always start on the left and head towards the right and see what happens. We'll use x values only x values, when we write down the answers for increasing, decreasing, and constant. Only x. And we'll also use only parentheses when writing down our answers. An individual point does not increase or decrease. Rather, it is just there. It's a point. But a line would increase or decrease or be constant. So we're not going to use any brackets at all, only parentheses. So I have a graph drawn here on the screen. Let's take a look at this in terms of x. Alright, so we're going to look along the x-axis. And we start on the left. So the first point that the function starts at is right here. And let's count over and see what that value is. -1, -2, -3, 4, 5, and -6. Alright, so at -6 right here on the x-axis, we have our first point of the function. And let's see what happens. Now, as we head towards the right, the function is going up. So I'm going to put an I here for increasing. And where does it stop increasing? Well, it stops at this particular point right here. And this point on the x-axis has a value of -3. Alright, so I can write down that this function increases from -6 over to -3. Now I'm writing these in terms of x values and using parentheses. Alright, let's see what happens next. Next, we encounter this point, and the function is going down to the next point. So this is where it decreases. So it starts decreasing at the same value that we left off with, at -3. And it goes over here to this value, which is at +2 on the x-axis. Alright, so I'm going to write decreasing from -3, comma, over to +2. Now, let's look at the next part. As we head towards the right, the function is going up. You can see that. And this would be the increasing portion. So we have a couple places that the function is increasing. So it starts increasing at the value 2 where we left off. And then it goes up to this point. And let's see what the x value is here. That would be over here at 6. So we would write increasing from 2 over to 6. So when I add it on here to the answer, I'm going to put a special symbol called a union. It basically means and. It's increasing in 2 different spots. And the last part, you see that the function stays the same, or is constant as we head towards the right. So it's going to be constant from the value 6 over to the value infinity. Notice that there's an arrow at the end of this. It keeps on going to the right. It would be going to infinity. Now, if we had an arrow on the left side over here, it would be going towards negative infinity. Sometimes you'll have those in the answers. Alright, so constant from 6 over to infinity. Since we're using parentheses, we don't need to worry about any open points or open dots at all. So that would be our answer for this problem. Okay, in this next problem, we will be looking at a different function where we have to graph in the calculator. It's f of x equals 5 minus the absolute value of x. So the first thing I'm going to do is press the y equals key. And I need to type this in, so I'm going to hit 5 minus and then hit the math button to get the absolute value. Now after I press the math button, I need to press the right arrow to highlight the number menu, and number 1 is ABS, or absolute value. Now after this, I need to press an X. It's the absolute value of X, and then close the parentheses. Now to make sure everyone's calculators are on the same settings, I'm going to press Zoom Next, Zoom at the top, and then number 6 for a standard window. And here is a look at the absolute value, and it has an upside down V shape to the graph. So I'm going to go and draw this on my screen over here on the left. So here's a quick sketch of the graph, and if you notice that the value is up here at 5. Alright, now we're not going to use any Y values though when writing increasing and decreasing, so I'm going to mark that one out. And actually come down here and notice that this point has an X value of 0 right here on the X axis. So, taking a look at this graph, starting on the left, we'll head up to this point. So this is increasing, and then over here on the right, the function heads down, so it's decreasing. So let's write down and figure out where it's increasing. Well, the function's coming from the left, and at the very left of the x-axis is negative infinity. That's where it's heading towards the left. And the function goes up to this point, and the value of that point is 0. So it's increasing from negative infinity over to 0. And then let's look at the decreasing part. It starts decreasing at this same point, which is at 0, and it goes to the right forever, which would be infinity. So I'm writing down that it's decreasing from 0 to infinity. And that would be the solution. We'll get back to some more increasing and decreasing in a minute. But now I'm going to move on and talk about relative maximums and minimums. A relative maximum is the highest point in a particular area or region on the graph. And a relative minimum is the lowest point in a particular area or region on the graph. I tend to think about maybe the top of a hill or a peak. We would have a maximum, and then a minimum would occur if you have a low point, kind of like the bottom of a valley. So this would be our valley, this would be our top of our hill up here, or the peak of it. So looking at this graph that I drew at the bottom, you can see that the function is coming up, so it's actually increasing as we head towards the right. And it increases to a certain point, and then it starts to go down and decrease. So where we have a change of direction is another way to look at this. A change of direction means we have either a relative maximum or relative minimum. So if it's increasing and then decreasing, this is like the top of a hill, this is a relative maximum. Now, so as a function decreases, it goes down to a certain value, a certain point, and it changes direction, and it is now increasing over here on the right. So, where the function changes direction, we have one of these relative maximums or minimums, and this is like the bottom, the low point, this is a relative minimum. Now we're going to find relative maximums and minimums in the calculator. And before we do that, let me write down what we just found out though. The function increases and then changes to decreasing when we talk about a relative maximum. So this would be increasing to decreasing. And then down here at the relative minimum, the function is decreasing and then increasing. So it's where it changes direction from decreasing to increasing. Now going on to the next problem, we have y equals x squared minus 8x plus 19. And I'm going to figure out the maximum or minimum and also where it increases and decreases. So the first thing we must do is type this in the calculator to graph it. So it's the y equals button. I'm going to clear out the previous function, and I'm going to type in x squared minus 8x plus 19. And then I'm going to press the graph button. So our graph looks like this. And you see that we have a low point, a minimum down here. And let's see if we can figure out the values of this minimum. Now, in order to figure this out, we'll need to go to our calculator and give it some commands. So, in order to figure out the values of the minimum or maximums, you press second trace for the calculate menu. I'm going to go down to number 3 and choose minimum. And then I need to do a few things and give it some boundaries so the calculator will be able to find it. Now I'm going to press the right arrow right now because the cursor is off the screen. So keep pressing the right arrow until you see the cursor come down here a little bit. And it appears on the screen eventually. Now we know the minimum is the lowest point right down here. Now the calculator needs a left bound or a place to the left of the minimum. Now you don't need to worry about these numbers at the bottom. We're concerned only with the location of the cursor. So the location of the cursor is definitely to the left of the lowest point. So this would be a good left bound, just anywhere on the left side. So I'm going to press enter now. Next, the calculator wants a right bound. So I need to move my cursor over to the right. I'm going on the right side of the minimum. So anywhere over here will work. Again, forget about the numbers at the bottom. Anywhere on the right side of the minimum is sufficient. So I'm going to press enter now. And then it says guess at the bottom. So I'm going to go back with my left cursor, left arrow, and move it to the very bottom where the minimum is, and that will be my guess. So I'm going to press enter. So the calculator does the calculations for us. You see that the x value is at 4 and the y value is at 3. So when we talk about the lowest point or the highest point, we're actually looking at the y value. How high or how low a function is always the y-axis because it runs from the bottom to the top. So when I write this down, I'm going to write the y value of 3 first and then the x value of 4. So y equals 3 when x equals 4 is our relative minimum. Now I'm going to take a minute and draw this on our screen. It's over here at 3 on the y-axis, 4 on the x-axis, so we have our point, and the function went like this. So the point is 4, 3. Now, when I talk about the increasing and decreasing, remember that we use only the x values. So I'm going to cross out the 3. That will not be used at all. And let's take a look at what happens with this. Now, as we head towards the right side, we see the function is going down or decreasing down to this value, this point at 4. Now, where is it coming from on the very left side? Well, it keeps on going forever this direction, so it's coming from negative infinity on the left side of the x-axis. So it's coming always from negative infinity if you have an arrow going to the left. And it comes over at 4. So this is decreasing, negative infinity, comma 4. Now, the increasing part, the function is increasing over here on the right side. It's going up. It took a turn. It's going up now. And it's heading over to the right forever. So if it heads towards the right forever, it's going over to infinity. So increasing would be from 4 to infinity. So that's how you find a relative minimum and write down the increasing and decreasing part when you're using your calculator. Going on to another example. Here we have y equals negative x to the 4th power plus 5. Now let's see what we have here. I'm going to press the y equals key and type this in. Be sure to press the negative button at the bottom. X to the 4th plus 5. And then graph. Okay, so here is our function. This is like a mountain or a hill, and we have a peak at the very top. So right here at the very top is where we have a relative maximum. So I'm going to start by drawing this on the screen. Okay, so our function goes kind of like this. A quick sketch. Up here at the top, we have our relative maximum. Alright, so let's figure out what the values are. So I'm going to press second, calculate, and go down and choose number 4, maximum. And we have to do the same thing. A right bound, a left bound, a right bound, and a guess. Alright, so starting with the left bound, I'm going to move the cursor over some. I like to give it some room away from the actual point we're trying to find. So this is an area on the left. Again, ignore the numbers at the bottom. We're only looking on the left side. So you press enter at that point. Now press the right arrow and go on the other side of the maximum. Okay, now this is going to be on the right. Now you see it's on the right side now. I'm going to press enter again and enter for a guess. So now we have some values at the bottom here. Now notice this x value doesn't make much sense. It says it's 2.15 e to the negative 4. Well, that's scientific notation where you would move your decimal point over to the left 4 places. So if you do that, you're actually getting 0. And use a little bit of common sense here. Look where this point is. This point is at the value 0 on the x-axis. So that's how you know, really. It's 0 for x, and then you see y is 5. So if you ever see this in your calculator, just keep in mind that it will be 0. So y is 5, x is 0. For our relative maximum. 5 is the high point. Now, when we talk about the increasing and decreasing again, we're going to use only the x value. So we're going to use 0 right here. And let's see what is happening. Now, the function is heading to the left, and it's going to be going over to negative infinity on the very left side of the x-axis, and then the function's heading towards the right, it's going to head over towards positive infinity. So keep in mind, only the x values we're concerned with. So, taking a look, starting on the left, heading towards the right, we see the function is coming up here to this point, so it's increasing, and you can see that it's increasing from negative infinity over to 0. There we go. Now, what about the decreasing? Well, it's going down as we head towards the right. So it starts decreasing at 0 over to infinity. And there's our answer for this problem. Now let's put it all together and work one more problem. And this one will have a relative maximum and a relative minimum. So we're going to start by typing this in the calculator, pressing the Y equals key and clearing out what I have in there from before, and then I'm going to type this in. Okay, make sure you get all your decimal places in there and your powers are correct. Make sure you're typing things in exactly how it's written down. Now I'm going to press graph. And here's a look at the function. We've got a hill right here, so that means we have a relative maximum. And then we have a valley down here, a low point, a relative minimum. So I'm going to give this a sketch on my paper over here on the side of the screen. You need to draw this out. Okay, there's a sketch of the function. So I'm going to label what we have. Up here is the top of the hill, the peak. We have a relative maximum. Down here at the bottom, it's like the bottom of a valley, it's a relative minimum. Now before we go on, we need to figure out what those values are. So I'm going to go back to my calculator. I'm going to press second, calculate. And I'm going to do the maximum first. So I'm going to go down to number 4 and choose that command. Now you need to bring the cursor up here to the maximum. So I'm going to press the left arrow until it gets up there. And we're looking for a left bound, so I'm going to keep on going past it and take the cursor on the left side. And you see that we're on the left side here, getting a little bit too far down. I like to get kind of close to the maximum, but far enough away for it to calculate it. So here is a good left bound right in this area. So press enter. Now I need to give the calculator a right bound. So I'm going to head towards the right. Again, give it a little bit of room. Don't get really close to the top. Okay, this will be my right bound. It's definitely on the right side of the high point. Press enter. And then guess. I'm going to bring the cursor back up. And the high point somewhere up there, I'm going to press enter. So the calculator finds this value for us. The x value is negative 3.51 and the y value is 8.44. So let's go ahead and write this down. We have a relative maximum. I'm going to write the y value first. That represents the height of 8.44. And the x value was negative 3.51. Okay, I'm going to get ready for this relative minimum. And let's see what values we get with that point. Okay, so we start over again. We're going to press second, calculate, and choose number 3, minimum. So I'm going to head over to the right and get closer to this minimum. Okay, but we're looking for a left bound. So for my left bound, I'm going to keep it over on the left side. You see it's right here on the left. So I'm going to press enter. Now I'm going to head over to the right side. Give the calculator a right bound. That'll be fine right over here. Definitely on the right side of it. And then let's head down to that special point, that minimum. And it's right about there. I'm going to press enter for the guess. So take note that we have values of 2.85 and negative 4.42. So again, I'm going to write the y value first. That's how low it is. It's at negative 4.42. And the x value was 2.85. So we took care of the maximums and minimums. Now we have to find the increasing and decreasing. Now remember that these are only the x values. So I'm going to take these two x values that we found, and I'm going to put them here on my graph. We know that the relative maximum is at negative 3.51, and the relative minimum is at 2.85. So I'm going to use those x values when I write down this increasing and decreasing. So starting on the left, let's follow the graph, and you see that it's going up, so it's increasing over here, and it's coming from the left, which would be negative infinity. So it's going to increase from negative infinity up to this point, which is at negative 3.51. Now let's look at the next part. After this point, the function is going down, so it's decreasing from point to point. Okay, so it's decreasing from the same value, negative 3.51, and then it goes down to this point, which is at 2.85. So I'm going to write these down, negative 3.51 over to 2.85 is decreasing. Okay, and on the very last, on the right side, we have the function coming up. So it's increasing over here. So it's heading over to infinity since it keeps on going to the right. So for the increasing, I'm going to write 2.85 comma infinity.